Hello class. In this video, I'm going to show you how to use the central limit theorem to find the probabilities. Let's take a look at this question. The overhead reach distances of adult females are normally distributed with a mean of 200 centimeters and a standard deviation of 8 centimeters. And we need to complete the following three parts. The given information tells us a population. I'm going to use X to represent the population. It is the random variable represent the overhead reach distance of a adult female. It's given that this random variable is normally distributed with the mean and the standard deviation given. Mean is 200, sigma standard deviation is 8. So that's the given information. We have a normally distributed population. X here is the population representing the overhead reach distance of adult females. The first part is to find the probability that an individual distance is greater than 212.50 centimeters. The first part of the question has nothing to do with the central limit theorem. It is an application of normal distribution. It's to find the probability when the variable is normally distributed. One individual distance is a value of the variable x. So part A is to find the probability of x is greater than 212.5 centimeter. And let's recall in previous sections, we have learned how to use TI-84 calculator to find the probability of an event. If the event is a normally distributed variable bigger than a value or less than a value in a certain interval, we can use the function normal CDF. As you can see, you go to second on the TI-84 calculator, go to second verse, and you will see the distribution manuals. In the manual, find normal CDF function, and then enter 212.5 as the lower limit because the variable is bigger than that value. So the value 212.5 is the lower limit. Upper limit is infinity. It doesn't have an upper bound for x. It is infinity. Infinity, we use the trisecond comma means double E and then 99. That means infinity in calculator. And knowing the mean is 200, we are not having a standard normal distribution. We have a normal distribution with mu equals 200 and sigma equals 8. So you're gonna let the calculator know mu is 200, sigma is 8. And then you solve for the probability and then round properly. So that's the first part. The first part actually is a problem similar with the problems we have done in previous section. Part B is about the central limit theorem. Let's look at the part B. Part B, find the probability that the mean for 15 randomly selected distances is greater than 197.8 centimeter. Part B is to find the probability that the mean for 15 randomly selected distances, that is the mean of sample means. Okay, this actually is sample means. So we can use X bar to represent the mean of sample means for the samples with size 15. From the population, we can randomly take many samples with size 15. And for each sample, we find the mean. So for example, the first sample, we find the mean x1 bar, second sample x2 bar, and so on and so on. We can find many sample means. And we know those sample means based on the central limit theorem is normally distributed because the original population is normally distributed. The requirement for applying central limit theorem is met. The requirement says either the population is normal or even the population is not normal, but the sample size is bigger than 30. In this case, the sample size is not bigger than 30, but doesn't matter because the original population is normal. So the central limit theorem applies. By the central limit theorem, we know those sample means are normally distributed, okay? I use X bar, capital X bar, to represent the sample means. Let me rewrite it. X bar represents sample means of X with size 15. Okay, yeah, X bar represent those values, sample means of the population with with size 15. Because we know those sample means, their average target the population mean from the previous section, right? Okay, so that means for part B, we are looking for X bar, the sample means. We are looking for sample means bigger than 197.8. What's the distribution of sample means? Based on the central limit theorem, sample mean here is also normally distributed. But the mean is the population mean, the same with mu equals 200. And the standard deviation is sigma over root n. Okay, standard deviation is population standard deviation divided by square root of the sample size. So that means for the sample mean variable, the random variable that represent the sample means of the samples of size 15 from the population is normally distributed with mean 200, standard deviation 8 divided by root 15, right? 200 is the mean of the normal distribution of X bar. Standard deviation is population standard deviation divided by square root of the sample size. We can still use normal CDF function in TID for calculator to find the probability. But this time, the lower limit is 197.8 because we're looking for X bar bigger than 197.8, right? The upper limit is infinity. But the mean is 200 and the sigma is 8 over root 15. So this is the part you need to fix, you need to update. You need to modify the value for sigma for the sample means, sample means are represented by the variable X bar here. All right, I hope this is clear. Part B is the application of central limit theorem. Be aware if you are applying central limit theorem, you need to adjust the standard deviation for X bar. It's not sigma anymore. It's going to be smaller than that. Divide the population standard deviation by the square root of sample size. Part C says, Part C asks, why can the normal distribution be used in Part B, even though the sample size does not exceed 30? Is it right? The sample size is not bigger than 30, it's only 15. However, the original population is normally distributed. And the requirement for applying central limit theorem is still met. The requirement says either the population is normally distributed or the sample size is bigger than 30. And this one of them is met, right?